Which of the following statements regarding active transport is correct? So let's just break it down, passive transport versus active transport, so we can understand how to answer this question. So just in general, if you think of the word passive, it kind of just allows things to happen. There's not really much effort, just thinking of the word itself, passive. If someone's a passive person, they kind of just take things as they are. They don't give really any resistance. And active, when we look at the word active, it's more of you need effort, you need energy, you're doing some level of activity, you need to work for it instead of it just happening. And those words kind of come into practice when we understand the difference in the definitions of passive transport versus active transport. Passive transport, it just happens passively. So if this is a membrane, so the outside and the inside of a cell, and let's say that you have 3 molecules in here, actually we'll make it 4 molecules. And let's say on the outside, you have 1, 2, 3, 4, 5, 6, 7, 8. So clearly you have more molecules outside of the membrane versus inside, and the gradient, just the natural way of flowing, goes from more concentrated toward less concentrated to maintain that balance and equilibrium, that homeostasis that we're referring to. So if the molecules start to move, so let's say this one moves inside, now you have 5 in here, now you have 6 in here. So now, if then this, let's say that it moves inside these two, now you have 6 on the inside and you have 6 on the outside, so it's balanced, equilibrium, and you don't need any extra energy to do so. It just moves across the gradient to balance, equal things out. As opposed to active transport, let's say that this was your membrane, and let's say that you had 1, 2, 3, 4, let's say you have 5 molecules on the inside, and let's say you had only 2 on the outside. So the normal natural gradient for the molecules to go to is from high to low concentration to move passively across, as we saw over here. But now we're looking at the active transport. So if you did want this molecule to get inside, it can't just easily go across the membrane as we saw at the passive transport. You would need something extra to do so, which would be energy in the form of ATP to move it across. Additionally, in order to move the molecule across, you also need a sort of transporter which acts as a vehicle to go along with the ATP for the active transport, and this works in the form of a carbohydrate or a protein. So if you think it kind of like if you're moving up a hill versus down a hill, the passive transport analogy of moving up the hill versus down the hill, you would think if you move down the hill, you could just easily roll. You don't have to put in too much effort. You just kind of go down. Versus active transport, if you think about going up a hill, it requires a lot more energy, a lot more activity, a lot more effort to go up. So you could think of going downhill as being passive and think of going uphill as active, if that helps you to remember the differences. So now that we understand the differences, let's look at the choices. We want to see which one relates to active transport, which one is correct. So option A says that it involves the transport of substances along the concentration gradient. And along the concentration gradient is what we saw over here with our passive transport analogy. Passive. So therefore, this would not be the correct answer because we're looking for what relates to active transport. So we can eliminate option A. Option B says that it requires energy in the form of ATP, and that is correct. As we see over here, we needed ATP energy in order to move during active transport, so option B is looking correct. Let's just review the last 2 choices. Option C says that it occurs through simple diffusion. And diffusion is actually another word for what we see here in passive transport. So this movement of molecule here to molecule there, that's what diffusion is. So that would be related to your passive transport. So we can eliminate option C. Then lastly, option D, which says that transporters are not required in the transport. And this is asking in terms of active transport because that's what this question is asking about. But as we discussed, you do need a transporter vehicle in order to use ATP to perform the actual active transport process. But option D is saying here transporters are not required. but we are looking for which is correct, and they are required for active transport, so therefore this would not be a choice which describes active transport, and option B would still be correct. It requires energy in the form of ATP in the process of active transport.